Okay, guys, chapter 3, exponential and log functions. All right, so the first part here is asking for the inverse. All right, so the inverse is when we switch the x and the y values. So we have now x equals -2 cube root y minus 1 minus 5. All right, so again, your goal here is to just solve for y. Okay, so we're going to add the 5. And then I'm going to divide by -2. So I have x plus 5 over -2. All right. Now to get rid of the cube root, I need to cube both sides. So that's going to give me x plus 5 over -2 cubed. All right. Now don't multiply that out because it's going to not be fun. So you can just leave it like that. And then the last part would be to just add the 1 over. So x plus 5 over -2 cubed plus 1 equals y. So my inverse is x plus 5 over x plus 5 over -2 cubed plus 1. Okay. Second one, we got x equals 2y minus 1 over 4y plus 3. Okay, so the first thing you're going to do is you're going to multiply the denominator over to the left side. So you got x times 4y plus 3 equals 2y minus 1. Okay, and then you're going to distribute there on the left side. So you got 4xy plus 3x equals 2y minus 1. All right, now keep your goal in mind, right? You're trying to solve for y. So everything that has a y term should be on the same side together, and then everything that doesn't have a y term should be on the other side. All right, so that's going to give me 3x plus 1 equals 2y minus 4xy. All right, now again, keep your goal in mind. You're trying to solve for y. So take out the y here. Now I could take out a 2, but again, you're going to eventually just have to divide it over. So it's easier just to leave it there. And then divide over. So 3x plus 1 over 2 minus 4x. So your inverse now, 3x plus 1 over 2 minus 4x. Okay, last one. You got 3 log base 5 of y minus 2 plus 4. Okay, so subtract the 4. And then divide by the 3. So x minus 4 over 3. Okay, now, in order to get rid of the log base 5, right, we're going to have to write it with an exponential. Okay, so this is 5 to the x minus 4 over 3 equals y minus 2. So 5 to what power gives me y minus 2? And then the last thing would be to just add over the 2. So your inverse now, five to the x minus 4 over 3 plus 2. Okay. So next part, evaluate each of the logs without the calculator. Okay. So just remember, guys, when you're doing these, you're doing, log of some base that's your kind of general setup. What you can remember is you're going to do your base to some power is going to give me what you're taking the log of, right? So it's the base to some power is going to give you what you're taking the log of. Okay, so if you know your exponents, you should be pretty good. Okay, so I got 5 to some power is 1 over 25. Now I know 1 over 25 is 5 to the negative 2. So my answer must be negative 2. If the bases are the same, their exponents are the same. So this one, I got 8 to some power is root 2. Now, both of these have a base 2. So this is 2 to the 3x equals 2 to the half. So you got 3x equals a half. So your answer, 1/6. Next one, 9 to some power gives me 1. Anything to the 0 power will give you 1. So 9 to the 0 power is 1. And then this one, now you can do it 2 ways, right? You can do log base 4 of 8 to the 5th, or you can figure out what log base 4 of 8 is and then multiply it by 5. I don't really know what 8 to the 5th is in my head, so I'm probably going to do the other way. Okay, so this gives me 5 times 4 to some power gives me 8. So this is 2 squared is 4, and then 2 to the third is 8. So 2x equals 3. So then x must be 3 over 2. And then what I'm going to do is just multiply that by 5 at the end, which gives me 15 over 2. Okay. Alright, now this one, if there's no base written, we know that it's base 10. So if I just do this first part, I got 10 to some power gives me 10 to the 1/3, so that must be 1/3, which then I'm going to just multiply by negative 3, which gives me negative 1. 38, I got e to some power is 1 over 5th root of e. Right, so anytime you're using the natural log, you're using base e. So if I rewrite, now I know my answer must be negative 1/5. Okay, now for 39, remember your rules, right? So if I do e to the, or I'm sorry, if I do the natural log of e to the x, it just gives me x. And then if I do e to the natural log of x, that also just gives me x. Okay, e to the x and ln of x are inverses of each other. So if they're next to each other like that, you can then just simplify them out. So this one, e to the ln of the square root of e, this and this are just going to cancel. So you're just left with the square root of e. And then 40, so 10 to what power gives me 10, which is just going to be 1. And then on the bottom, e to what power gives me e, which is also just going to be 1. So your answer 3x. Okay, so the next one says sketch the graph and then determine domain, range, and the intercepts. Okay, so you guys should remember that your e to the x graph looks something like this. And it's going to go through 0, 1. All right. Now this one has a reflection over the x, and it's going to move it left 1 and down 2. Okay, so if I flip it over the x-axis, then I'm going to be at 0, negative 1, right? Now if I move that left 1 and then down 2 from where it's at right now, that's going to put me at negative 1, negative 3. Okay. Now remember, you have an asymptote for e to the x also at 0. So if it's originally at 0 and you move it down 2, that means that it's going to be at negative 2. Right? And then you can just draw your graph from there. Okay, so the domain is all real numbers, and then the range is going to be negative infinity to negative 2. All right, now the x-intercept, right, that's when we're going to set my equation equal to 0. So negative e to the x plus 1 minus 2. Okay, so negative e x plus 1 equals 2. And then e to the x plus 1 equals negative 2. Right, now to get rid of the base e, right, I have to take the natural log on both sides. So over here, it's going to give me x plus 1. But if I take the natural log of negative 2, I can't do that, right? So this is not possible. Right, I can only take the natural log of a positive number. Again, that goes back to its domain. So if this equation is not going to work, then there is no x-intercept. Now you guys should pretty much figure that out from the graph. We obviously did not cross the x-axis. And then the y-intercept, that's when we're going to plug in 0 for x. So negative e to the 0 plus 1 minus 2. So negative e to the first minus 2. So that is your y-intercept for 41. All right, so 42, starting with a natural log function, all right, which looks like this, with a vertical asymptote at x equals 0. Okay, so I have 2 natural log negative x minus 4 minus 3. All right, so we got vertical stretch by 2, reflection over the y. We're going to move it right 4, and then down 3, right? Now the point that I always go through for a natural log function is 1, 0. Now if I flip it over the y, right, that means it's going to go through negative 1, 0. Right? So that's kind of my starting point, is negative 1, 0. And then I'm going to take I'm going to take that point and I'm going to move it right 4 and then down 3. So if this is where I'm starting, I'm going to move it right 4 and then down 3. All right, now if I move everything right 4, my original asymptote at x equals 0 is now at x equals 4. All right, and then I'm just going to draw the graph. Like so. Actually, that's not good. All right, the domain, negative infinity to 4, because that's where your asymptote's at, and then your range is all real numbers. Okay, now x-intercept. Again, you set the equation equal to 0. So 2 natural log of negative x plus 4 minus 3 equals 0. So that's going to be the natural log of negative x plus 4 equals 3/2. Right? Add the 3 and then divide by the 2. And then raise both sides with e. So negative x plus 4 equals e to the 3/2. And then divide by the negative 1. So you got x equals negative e to the 3/2 plus 4. Okay, and then your y-intercept is you're just going to plug in 0. So it'll be 2 natural log of 4 minus 3. And again, I'm not going to expect you guys to figure that out. You can just leave it like that. So 0, and then 2 ln of 4 minus 3. All right, so again, just make sure you guys know your parent functions, and you should be pretty good with the graphing. Okay, so next part says expand or condense. All right, so 43 I'm going to be expanding. All right, so I see that I have an exponent, so I'm going to take that and move it out front. All right, now the 4 is multiplying the whole thing, like that. So I'm going to separate now the fraction, which I can do with division, or subtraction, excuse me. All right, now I can simplify log base 5 of 25. 5 to what power gives me 25, which is 2. And then my final answer should be 4 log base 5 of x minus 8. All right, that is completely expanded out. All right, 44, a lot of things going on. All right, so I'm going to just take it piece by piece. So I got natural log of 5x squared plus natural log of 2y minus 1 to the 2/3, okay, minus natural log of 2y and minus natural log x plus 1 to the 1/2. Right, so again, remember, if it's in the denominator, the term needs to be negative. Okay. Now I'm going to separate 5x squared. So that's ln of 5 plus ln of x squared plus. Now the next term, the only thing I can do is I can bring down the exponent. I can't separate 2y minus 1. I can't separate subtraction. You can only separate division or multiplication. So 2/3 natural log 2y minus 1. And then this one here was going to be ln of 2 plus ln of y. And then this one here, again, I can only bring down the exponent. All right. Now I only have like 2 more things to do. So ln of 5 plus, bring down the exponent, so 2 ln of x. And then I got 2/3 ln of 2y minus 1 minus ln of 2 minus ln of y, and then minus 1/2 ln x plus 1. Alright, it's a pretty long one there, but again, just take your time, and you should be okay with that. Remember, if you're expanding, nothing should have an exponent. All the exponents should be out front. Nothing should be multiplying together, anything like that. So, all right, 45 looks like I am condensing. Okay. Now the thing I see here is I have a minus 2, right? I need to think of log base 7 of something comes out to be 2, right? So 7 to the second power gives me 49. Now the reason I'm doing that is that now everything can be used with log base 7. So log base 7 of x plus log base 7 of x minus 3 minus log base 7 of 49. Okay, now that everything has a log base 7, I can now condense it. So now it's x log base 7 of x plus log base 7 of x minus 3. So I can multiply those terms together to make it x squared minus 3x. And then I'm subtracting log base 7 of 49. So that 49 goes on the denominator. Okay, and then the last one here. What am I going to do? Alright, so what I'm going to do is I'm just going to kind of rearrange some things here. I got natural log of 3x squared plus natural log of 2y squared minus 3 natural log of 2 minus 1/2 natural log of x. Okay, so I'm going to put the first 2 terms together, make that natural log. So 3x squared is going to be 9x squared times 2y squared. And then I'm going to move the 3 up, make it ln of 2 to the 3rd plus ln of x to the 1/2. So ln of 18 x squared y squared minus ln of, actually let's do this, minus natural log of 8x to the 1/2, and then because I'm subtracting the 2 terms, we got natural log of 18 x squared y squared over 8 x to the half, which then you guys can simplify and make it 9x to the 3/2 y squared over 4. You're just simplifying there. That's all you're doing. Okay, so 47 and 48 are change of base. All right, so if you have log base b of something, okay, and you want to change it to say be base a, so your new base is going to go on the top and the bottom like that, and then what you were taking the log of originally goes on top, and what you were taking your original base goes on the bottom like that, okay. So this one I see that I have a base 2 and a base 4, so it's probably best if I changed base 4 to be base 2. So log base 2 of x plus log base 2 x minus 1 over log base 2 of 4. Okay, so I got log base 2 of x plus log base 2 x minus 1 divided by 2. Now if I divide by 2, I'm really multiplying by a half, right? So I'm going to move that 1/2 up front, or up top, excuse me. And then, since now they're both log base 2, I got log base 2 of x times the square root of x minus 1. Alright, so that's how you are going to change the base on that one. Same thing here. It looks like I got base 2 and then base 1/2. So it's probably best if I change base 1/2 to be base 2. Okay, so I got log base 2 of x plus log base 2 x minus 1 over, now 2 to what power gives me 1/2? That's -1, which then makes this log base 2 of x minus log base 2 of x minus 1. Now they're subtracting, so I put them together with division. So log base 2 x over x minus 1. Alright, so that is your change of base formula. Okay, so moving on to equations. So 49, if you can get the bases to be the same, that's always going to be your first trick for exponential equations. So this is now 2x squared minus 3x minus 31 equals 2 to the third. To the negative third, sorry. So, same base, I'm going to set them equal. So that's now x squared minus 3x minus 28, which is then x plus 7. Nope, sorry. Minus 7, and then x plus 4. So my answers are 7 and -4. Now remember, an exponential equation, you don't really need to check your answers because an exponential function, the domain is all real numbers. So it doesn't matter if you get a negative. The next one, divide over the 1,000 So you get 2 equals 3 negative 0.1 t. Now I can't really get a similar base with base 2 and base 3. So just use natural log now to solve. So I got ln of 2 equals ln of 3 to the negative 0.1 t. So this is now ln of 2 times negative 0.1 t ln of 3. Divide the ln of 3 over. So you got ln of 2 ln of 3. And then the last thing you're going to do is you're going to multiply both sides by negative 10. So the negative 10 natural log of 2 over natural log of 3 equals 2. Okay. Next one is a log equation. So I see that I have a plus sign here, so that means I can make my factors multiply. Right, and then if I write it in exponential form, I get 3 squared equals x squared minus 16. So that's x squared minus 16 equals 9, which is then x squared equals 25, and then x equals 5 or negative 5. Now remember, because it's a log equation, you want to make sure that what you're taking the log of is positive. So if I do negative 5 minus 4, that's not going to work, right? So I'm going to get rid of that one, and it's just 5. Okay, so 52 gives me ln of x squared equals ln of 2 times x plus 12. All right, so if I'm taking the natural log on both sides, right, that means that their arguments must be the same as well. So x squared must be 2x plus 24. So then x squared minus 2x minus 24. You factor there, and I get x equals 6, and then x equals negative 4. And then, again, I'm not going to be able to use a negative answer here, so that one's out. So just x equals 6. All right, so 53, put them together. So you got natural log 2x minus 1 over x equals natural log of 2 to the 1/3 to the third. Okay, so this is 2 to the 1/3 to the third is really just 2. So that's 2x minus 1 over x equals natural log of 2. No, sorry. Just 2. And then that gives me 2x minus 1 equals 2x. Which then, if I subtract the 2x over, I get negative 1 equals 0, which obviously is not possible. So this one, there is no solution. Okay, and then 54. It looks like I have a bunch of terms here that I could probably write in terms of 5. So that's what I'm going to do. So 5 to the negative 2 to the x plus 1. And then the square root of 5 to the 40th is really 5 to the 20th. And then I got 5 to the 3rd over 5 to the 1/2 to the 2x. So then this is 5 to the negative 2x minus 2 times 5 to the 20th equals 5 to the 5/2 to the 2x, which is then 5 to the negative 2x plus 18 equals 5 to the 5x. So that's negative 2x plus 18 equals 5x. So that's 18 equals 7x. So 18 over 7 is your answer. Alright guys, so that is part 1 of chapter 3, and I'm going to come back and I'll do part 2, which are going to be all calculator questions. So you definitely want to get that out.